Hello, everyone, and welcome to another episode of TD 202. In this episode, you will learn how to draw isometric circles. Stay tuned. Now, when drawing circles in isometric projection, we don't employ the same means or methods as used to draw circles regularly, meaning we don't just simply open up our compass to the required radius and draw the circle. We have to go about constructing the circle. Why is this? This is so because circles in isometric projection, they don't appear as circles to the naked eye. They appear as an ellipse. So this is an isometric circle, right? The reason for this is due to the fact that isometric projection is trying to give a realistic view of whatever shape you're drawing. So for example, I have this roll of tape here, and as you can see, it is round. This is looking at it from a plan view or from an aerial view or a bird's eye view. Now, in isometric projection, more than one views are being shown at once. So if I want to see the front of the tape or the sides, this is the view, plan view, side view. Now, in isometric projection, you will see the tape in a 3D view so as to show multiple angles at once. So, as you can see, this circular portion now takes the shape of an ellipse. So, in drawing a circle in isometric projection, we're actually drawing an ellipse. So let's get started. We are going to draw a circle of diameter 10 centimeters or 100 millimeters. All right. So let's go ahead. The first thing I'm going to do when drawing an isometric circle is to draw an isometric square. And by drawing an isometric square, we are actually drawing a rhombus because the shape in isometric projection is skewed to show a realistic view of the shape. So I'm going to draw my axis lines. And you have to bear in mind in isometric projection, when you are measuring the sides, you have to be absolutely accurate, as this will throw off your results. So I'm ensuring that my isometric square is to perfection in terms of the length of the lines as well as the angles that I'm producing with my set square and the t-square combination. if it is off even by a millimeter, the circle will be thrown off. I'm going to see if I can make my construction lines a bit brighter so that you can see them. But normally your construction lines would be dull, very light lines. So I have now drawn my isometric square. Okay, so that's the first thing you'll do, is to draw an isometric square. The next thing that I will do is I am going to draw, or find rather, the center of this square, or divide the square rather in 4 quadrants. These quadrants will also serve as quadrants for the circle that we will draw later on. So since one side measures 10 millimeters, half of that side will measure 5 millimeters. I only have to measure 2 of the 4 sides and then transfer the measurements to the other 2 sides. Now, really and truly, these should be center lines, but some persons use construction lines as well to do this particular exercise. For the sake of this exercise, I'm going to label my points. So I have point A, B, C, and D. I have point 1, 2, 3, 4, and this central point. Okay, so now that I've divided the square, the isometric square, in 4 quadrants, the points that are established as a result, point 1, 2, 3, and 4, will be used to construct the circle. Now, I need 2 more points. There are a number of patterns that can be created to achieve the points. Now, I can create a V pattern, an A pattern, an N pattern, or a combination of 2 of these patterns, of a V and a A. So let's start with the A. In all of the patterns, regardless of the ones that you're using, you have to connect the longer diagonal, or draw the longer diagonal of this shape, of this rhombus. Now, since it's a quadrilateral, you will have 4 points, 4 lines, 4 vertices. Now, you are going to connect the longer vertices, which will give you the longer diagonal. So it would not be BD, it would be AC. After you have done this, you are going to proceed to create, I'm going to create an A pattern in this scenario. So I'm going to connect D to 3. So I'm connecting the one of the points from from the shorter diagonal, which is here, to the two opposite points from the quadrant. So this is a quadrant, this is a quadrant, this is a quadrant, this is a quadrant. So I've gotten my A pattern. Now if I had drawn it from B to 4 and from B to 1, you would have gotten a V pattern. Let's do that. So now you have your V pattern. This is the V pattern. This is the A pattern. Now I have a combination of the V pattern and the A pattern. When you have a combination of the V pattern and the A pattern, you can know for sure that this point is correct, because all three lines will be passing through this point. This line, and this line. The same thing for over here. I'll call this point 5. I'll call this point 6. Now, you could have just gone ahead with the V pattern or the A pattern, which would result in two lines intersecting at each point, right? But you would have to ensure that your drawing is accurate, which shouldn't be a problem if you're following the correct procedures. However, if you employ the use of both A patterns and V patterns, you will know for sure whether or not your drawing is accurate. And as you can see, all three lines are intersecting, which means that the drawing is accurate. Now I made mention earlier about N pattern, which is this. I call it the N pattern. It's not really an N per se. So you have this, you could have just drawn this line and this line. There's the N. The N is formed this way or this way. From B to 1 to 3 to D. That's the N in the pattern. Or the reverse. D, 2, 4, B. No, the aim is to get this point. So you could have just drawn the V to get this point and this point, or you could have just drawn the A, because the A and the V would intersect with the longer diagonal to give you the points. So let's go again. Now it's time to utilize our compass. Now, in utilizing the compass, you are going to use the following points. Point B, point D, point 5, and point 6 in this rhombus that is formed here. Okay, so let's start off with points 5 and 6. Point 5, you're going to draw an arc from the closest points to 5. So I'm putting my compass point at 5, I'm opening it to 1. 1 and 2 is the closest points to 5. Right? Closest numeric point and closest point overall. Now, if your drawing is accurate, when you swing the arc from point 1, let me tighten my compass a bit. Now, when drawing isometric circles, the better your compass, the better the result. When drawing the point from 1 to 2, if you notice that they are not connecting, it means that your drawing is somewhat off. So let's see if mine is correct. And you are pressing on the pencil because in this case, the circle needs to be brined. So, my drawing is accurate, or at least for the most part. You will not be able to see any form of inaccuracies from what I'm doing based on the camera. So, if for some reason the arc is not lining up with the points, it simply means that your drawing is inaccurate. Let's go over here. I should not need to change the arc. So point 6 would be connected to the 2 points labeled that is closest, which is 3 and 4. And there it is. Now, the next 2 points that I'm going to use is points B and D. So earlier we used the point A and the C to draw the diagonal, the longer diagonal. Now, the points that are closest together, the opposite points that are closest together in the square, will be used to draw or to finish off the circle. Notice this quadrant, use the small circle. This quadrant, use a small arc rather. Now large arcs are going to be used at point B to connect 1 and 4. You have to ensure that the compass that you're using is able to stretch, and you have to ensure that it doesn't shift in the process. So it's going to connect 1 to 4. And the last, let me brighten that a bit. Brighten that some more. And the last circle or arc that I need to draw will be drawn by placing the compass point at D and drawing it from 2 to 3. I have a little issue with the compass point here. Come on, compass. Okay, here it goes. Now this is where a good compass, a very good compass, will show up a very poor compass. Now this is the final arc. So there you have it. An isometric circle. Now let's review the steps. Okay, so let's recap. So the first thing that we did was to draw a square, an isometric square. And in doing so, we have to ensure that the diameter of this circle that we want is equivalent to the length of one side of the square, as stated here. Next thing that we will do, that we did, was to divide the square in 4 equal parts. The third thing that we did was to fill in the longer diagonal, right? By connecting the furthest points in the furthest vertices rather. These points are vertices, one vertex, multiple vertices, right, of the square. So A and C is furthest apart, B and D is not as far. Okay. Then we draw 2 lines from any of the 2 vertices from the shorter diagonal. This is the shorter diagonal. We can use any other points. ensuring that the lines connect to any of the 2 points that results from the division of the square. So B will be connected to 4 and 1. You could have done D to 2 and 3. You could have also done D to 2, B to 4, or D to 3, B to 1. Any 2 points should give you 5 and 6. Once you have done that, we can now proceed to use this point, which are the points mentioned here, as well as this point and this point. So the points created, 5 and 6, will be used to draw the smaller circles or smaller arcs, while the points on the vertices will be used to draw the larger arcs. Please note that once you note all of those little pointers, you will be able to draw the isometric circle with ease. I hope you guys learned and grasped the concept that was taught today. Please remember to share this knowledge by sharing the link to this video, subscribe to the page, like the video, and share the content. Have a good day.